Yeah.
That would just scare me.
It's pretty creepy. Well, not creepy, but like. Tesla's self-driving. Yeah, Tesla's self-driving, but like my brother's new Volvo, like if you just put that on and you're about to like steer out of the lines, it'll bump your car back in. So
Oh, while you have to hit a button to give it that control, right? Or is it
yeah.
on? Okay.
You can, but also if you just let your hands go, it'll, as long as it's like straight enough.
Okay. Because I was thinking the number of times that I've actually had to pull off the side of the road. I was trying to picture, you're pulling off the side of the road and suddenly the car says, no.
It'll definitely like fight you a little bit, but if you jerk it, it'll be like, okay, you want to go that way.
Okay.
I don't think I like that.
Yeah.
My dad's truck just has the thing where like if you start getting out of the line, his seat has little motors in it and it'll like vibrate one side or the other depending on where you're looking. Which is a lot better than I think.
It sort of wakes you up.
Yeah, well it's just like letting you know, it's like you're drifting towards this side or that side.
Okay. I can deal with that better.
I feel like I'd overcompensate if like it was fighting me. I wanted to go over and go over, you know.
It's very subtle.
You start swerving in the lane like that constantly.
Fighting with your car.
Yeah.
Yes, been there, done that. Something flashed into my first major accident. All right. So we've pretty much covered chapter 35. So I would like the quiz on chapter 35 to be on Monday the 16th, the day before spring break.
What's that? Yeah, I'll come back.
Probably one more topic I'm going to hit from chapter 35, but I'm not going to do it right now. Any questions before we actually bring it into lenses? Simple lenses. I probably should set my alarm so I can talk about the class. Back. All right. So set it for 11:45. So later on, when you're telling tales of, we spent time in class where he was just playing on his phone. We're videoing this, so it'll be safe for immortality.
Do you put all your lectures on YouTube?
No, just when I remember. When I remember, I do.
Do you do it more often when students miss?
It's more, in fact, I do it when I remember to do it.
Okay.
This might be the second one I've done for your class. 152, I tend to be a little bit better on, but that could be because that phone belongs to someone in 152, and that triggers the memory. All right, so since light bends going into glass, if I have a lens like this, some central axis, I have light coming in. It's going to hit this and it's going to bend. So if we think about the normal here, so I have, let's see if I can draw that a little bit more neatly. I have light coming in, I'm going to have it come in straight. It's going to bend using Snell's law based upon that index of refraction and the angle in which it hits. So that is the normal right there. So it's hitting at some angle of incidence. It's then going to bend, since it's going from, let's say, air to glass. It's going to bend closer to it. Then it's going to hit this other wall right here. and it's gonna bend away from that because it's going from glass to air. Let's see, that's straight ahead, so that angle's that. It's gonna bend away from it. Now, the light coming out is not parallel to the light coming in because this is not flat, it's curved. The example that we did before, and I wrote it on the board over there, is that was a flat plate. It would come in, the angle coming out of the glass was parallel to the light coming in, but offset. Here, it's not because of bent. And so this is actually going to hit some point around here. Matter of fact, if it's designed properly, any light that comes in parallel will all hit this same spot right here. And the spot is called? Focal point? Yep. Or just as one word, focus. Now, this is a convex lens because it's bulged out. Concave lens, just like with a concave mirror, it's sort of curved the other direction. So if we draw my attempt at a concave lens, and so light with some central axis. So light coming in, parallel. We have our because it's going from air into glass, it should be closer to the vertical than that was. And so that would be if it went straight, so this would be curving that way. It's going to hit this lens part right here. Again, that's my normal. And because it's going into air, it should bend farther away from it. So that would be as if it goes straight. So then it should be going like that. So at the convex lens, the light comes in towards it. So this is also known as a converging lens. And this is known as a diverging lens. So obviously, if you need light to spread apart, concave or diverging lens. If you need it to focus in, convex lens. So magnifying glasses, for those of you who spend some time burning things with a magnifying glass, this is what you're working with. Now, if we look at the eyeball, all right, so we've got our hole right there, and we have retina back here. This is the retina. The pupil, which is basically a hole for the light to go through. There's a lens here in your eye. So for those who have had cataracts, or hopefully none of you have had cataracts at this point. We have a lens right here that inside the eye to help focus the light onto your retina. But some of us have sort of a built-in humble factor. This is what keeps us humble. For those of you who don't wear glasses, I don't know what keeps you humble, but for the rest of us, it's a little bit distorted. If it hits too early, this is nearsighted. Farsighted people, it focuses it too late. So this is for farsighted people. So, if you're nearsighted, what kind of lens do you have?
Concave? Convex.
You changed your mind?
I'm guessing.
Why did you originally say the first one?
Because I think did I say concave first? I think I said concave.
You said concave first.
Because it. How did I say it?
It's I heard somebody else over here say
It was a
convex
guess.
right before you changed it.
It was a guess.
Convex.
Why is it convex?
Because you said that was like the magnifying glass you needed to magnify because you can see close but you can't see far.
Except for nearsighted, it's already focusing early on. You want it to focus farther.
So it's making the focal point further away? Is that what it'd be doing?
Yeah, in essence, it's making the net focal. Because you'll end up with a 2-lens system here, and we'll talk about that at some point. But yeah, light comes in, you do want it to focus farther away than what it was. So therefore, which of Curtis's answers was correct?
Concave.
Yeah, you want a divergent lens.
Told you guys.
So if you're farsighted, yeah. So if you're lost in the woods and you're farsighted and you've got the sun supply right there, you can start a fire just by, with your lens like that. However, if you're nearsighted and want to start a fire with your glasses lens, then no, that's not going to work. Except there is actually a way.
Flip it?
No, flipping it doesn't work, unfortunately.
Use 2.
Could you actually do it with 2? That's possible. Because in reality, I mean, if you look at it, it is sort of both. It's got a convex and a concave side to it. It's a question of which one is more bent. We'll eventually derive the lens maker's formula. But if I've got something like that, this is bent a little bit more than that side is the way I've drawn it. Or you could go like that as light's coming in. So depending on the relative relationship there, if I did take the other lens and put them like that, I'll have to think about that longer. There is another solution. How can you turn a concave lens into a convex lens without grinding? I was just curious if someone would think of it. Add water. Water has an index of refraction of, that already looked that one up. That's 1.33. Glass was 1 point, depending on the time of glass, 1.5 or so, 5.2 or 6.3. In theory, this works. Anytime I've ever thought of it has been an overcast day. So some sunny day, I'm going to actually think about it. Actually, next time we have a sunny day,
Field trip.
we should go outside and see if we can burn something with my glasses. If nothing else, my glasses get clean.
Yeah, I'm nearsighted, and my sister never knew how I saw without glasses until like Finding Dory came out and the whale shark.
Say that again?
Because my sister doesn't need glasses, she can see perfectly. And I'm nearsighted, so she's just like, how do you like see without your glasses? I was like, it's all just like, if you took like a water painting and just went like that to it, I was like, that's how it is. She just didn't understand. And Finding Dory came out, and there's like a whale shark in there that's also nearsighted, and it shows from like her point of view. And then I showed her, I was just like, that's how I see.
Okay.
And she's just like, that's horrible. I was like, yeah.
Yeah, I made the comment about keeping us humble. So the way I view it is everybody has a couple things that keep them humble. So we got one out of the way with this, which just allows us to be giants at something else. Yeah, my brother didn't have to wear glasses till he was 50 or so. Now he has reading glasses because he's old.
Do people with prescription lenses look down on people with reading glasses?
I look down on my brother.
Call it poser.
Hey, he saw me do it and he thought, hey, the cool kids are doing it. So.
Yeah.
All right, so one thing about this, so we have a couple of rules that we come up with, and so one of the things we're dealing with is what's going to be known as the thin lens. Now, I don't know at what point it really goes from being a thin lens to not a thin lens. Typically, with most things, there's a 10% rule in there, like the thickness here is, so the thickness is, less than 10% of the length of it. But I haven't seen that in any formality. But we do have a couple of rules here. So even though it does bending inside the lens, inside the glass, the way I've drawn it right here, we can approximate the thin lens as a really thin lens with a central axis. Here's our thin lens. We'll make it a convex lens. So light coming in is going to then go through the focus because, of course, sun's rays meet. Light that is going through the center here. So if there's my object, the light going through the center of it should just go straight through. So very similar to what we did with the mirror, except the light's actually going through instead of reflecting. And so we end up with, if this is my object, this is my image. So let's go through a similar process we did before. We're going to derive the same formula as we had the first time, but let's do it formally anyway. So this is the point right here, is the point F0. This is some height of object. So this is the point 0, height of object. Again, doing ordered pairs, x, y ordered pairs. And so this point right here would be negative distance of object, comma, h of object. This is the point 0, 0. This point right here is distance of image, comma, height of image. Any questions about the notation I have written up there? All right, I have two lines here. I want to figure out where they intersect, so I need an equation for the two of them. I'm going to put it into y equals slope x plus b form. So I'm going to call this line 1 and line 2. That's not line 2. Line 2. What is the intercept of line 1? No. What do I mean by intercept?
Where is the lens?
Yeah, okay, yeah, in essence. I was more generically where it hits the y-axis or vertical axis. And so for line 1, it crosses at the origin right there, 0. What is the slope of line 1? How would you find the slope?
Y is over 1.
Yep. So my slope of 1, I'll just write b1 is 0. The slope, rise over run, I just need 2 data points. I have 3 here, but I just need 2, so why don't I just take those 2 right there. So I do 0 minus h sub 0 over 0 minus negative d sub 0. So I end up with negative h sub 0 over d sub 0. So height of object over distance of object. So my equation for line 1. Y is equal to negative h sub 0 over d sub 0 x at x. Line 2. What is the intercept for line 2?
0 and the height of object.
Yeah, so the intercept is just the y value, so h sub 0. And the slope?
supposed to be negative H?
Wait, where are you looking?
Line 2 for Y.
Oh, yeah, that should be, that, is that what you're asking about? Yes, that should be negative, thank you. All right, so what's the slope?
Is it negative h of 0 over d0 or d of object?
Would it be h of 0 over the distance of the image? Negative distance of the image?
No. What 2 points? Well, first off, what 2 points are we picking out? Because line 2 here, we've got 1, 2, 3 points. Which 2 are we working with?
I was looking at di and negative hi, but I guess you could just.
So you're looking at that one there?
Yeah.
And
The y-intercept.
so our slope is negative hi minus ho over di minus 0, which is negative hi plus ho divided by d sub I. So our second equation, y is equal to, yeah, so it's a negative, and it is, yeah, negative hi plus ho over d sub I x plus h sub o. So this is line 2. We now need to figure out where they cross. I know where they cross, the y values and the x values will be the same. So I guess we set them equal to each other and solve for x. So negative hi plus ho over di x plus ho is equal to negative ho over do minus x. Because again, when I have the same value of x, I have the same value for y. So I need to get the x stuff on one side, so let's bring this over to here. And so I'm left with h sub 0 equals hi plus ho over di minus ho over do times x. Which equals, see, I'm adding fractions here, so we need a common denominator. So my common denominator is di do. And so this becomes DOHI plus DOHO minus DIHI times x. And so x equals something relatively nasty. We need to simplify it at some point. So it becomes HO DI DO over DOHI plus DOHO minus DIHI. Not equals 0. Any Carol Sarahs in there?
Would it have been easier if we used f and 0?
Quite possibly. So that and that.
Yeah.
So if we did that one,
Like since you got some zeros in there.
so the slope would be equal to negative HO over F. That probably would be simple. So if I plug that into there, so we have y equals negative HO over F x plus HO, and we set that equal to negative HO over DO. Oh, okay. So let's get the x's on the same side, so bring this over. And so we have negative HO, so we have HO equals HO over Fx minus HO over DOx. What is the value of x though, at the point where they meet? Yeah. So this is HO, well actually HO cancels out because I have one in every term. So 1 is equal to 1 over F times DI minus 1 over DO times DI. Divide by DI, I get 1 over DI equals 1 over F minus 1 over DO, or 1 over distance to the object plus 1 over distance to the image is equal to 1 over the free focus. The exact same equation we had when we dealt with the mirror. But we have to interpret it a little bit differently. Convex lens, the light actually meets here. That part holds true, that if the image is real, in other words, the light rays actually meet there, if the image is real, it is positive. So, same as before, real image, distance to the image is positive. Or in the book term, Q is positive. This is the book. In the point where the light rays actually meet at the focal point, that holds true also. So if light rays meet at focal point, then the focal length is positive. For a mirror, that means you're dealing with a concave one, so it comes in and then light goes through the focal point. For a lens, that means it goes through. So if I have a concave mirror, focal length is 10 centimeters. The distance to the object is 15 centimeters. Then 1 over 15 is 1 over plus 1 over the distance to the image is equal to 1 over 10. So 1 over distance to the image is equal to 1 over 10 minus 1 over 15, which is 1/30. So distance to the image is 30 centimeters. Concave mirror. Convex lens. Focal length is 10 centimeters. Distance of the object is 15 centimeters. The math is identical. Distance to the image is 30 centimeters. The difference is for the concave mirror, if my object is here, my image is going to be here. For the lens, if my object is here, the image is going to be here. But what's common is that light rays meeting generally gives you positive, you're dealing with positive variables. And diverging, since the light goes spreading out, there's only the illusion that the image is in front of it, potentially. All right, let me have that test. Today is the The second, I would like the test corrections by spring break. Same day as the quiz on chapter 35. If that Monday rolls around and you do not have the test corrections ready, just let me know when they are. What I don't want is for them to be hanging over your head for the rest of the semester. That's primarily why I have a 2-week deadline on that. So if you can't make the 2-week deadline, and realistically, because some of you might not have time until spring break. Some of you, spring break just means you're working your job longer. So depending on your situation. But so if it's not ready in 2 weeks, just let me know when it will be. Test corrections. I think we've talked before about how much it changes your grade, or could change your grade. I got some nods there, all right. Test corrections need to be on separate papers, however many you need. You are trying to demonstrate to me that you understand. Putting the correct answer down gets you nothing. And not in red ink. That's pretty much it. If 2 of you are working together, which is not inherently a bad thing, 2 of you are working together and both of you write down identical answers, you suddenly have not convinced me that either of you understand. It looks like one of you understood and the other one copied. So please make sure you express it in your own way. Okay. Any questions at the moment?
So before spring break?
Before spring break.
Same day as schools.
And I am planning to have class on that Monday. It is a regular class. And so yeah, I'm assuming everyone in here is going to be there. So we're officially done at 11:54. If I let you out a couple minutes early, please don't commit any crimes, because you have an alibi for the moment.